Hello, year 11 and welcome to our fourth video here for polynomials. Now, we looked at polynomial long division in our last exercise, and that's a very helpful thing to know how to do. I've got these things now that follow from it, or at least are associated with it, called the remainder and the factor theorems. And we're going to start with the remainder theorem, and that tells us that if some function of x is divided by, the term x minus a, then the remainder will be the function of a. Right? So if I have, for example, and in fact, here we go, here's an example, x cubed plus x squared plus x plus 1. If I divide that by x minus 2, now I can do the long division and work our way through that and find the remainder. That'll give me the quotient and the remainder, which are both good things, I suppose. But if it just says find the remainder, and often it does, then there's a shortcut to doing that, and all I have to do is substitute x equals 2 into that function. Okay, so let me show you how that's going to look. Right, now that I've got... Okay, no, just my screen's playing up. So, find the remainder. I'm going to say function, or p of 2, equals 2 cubed plus 2 squared plus 2 plus 1, okay, equals 8 plus 4 is 12, 14 is 15. There we go. What's the remainder? The remainder is 15. Wonderful. Now, moving along here. Now, if x cubed plus ax squared plus x minus 4 is divided by x plus 1, and I get some quotient minus 8, so I get a remainder of 8. Find what a must be. Right? Well, that tells us that if I substitute x equals -1, right, we change the sign of that there, right, because I want the 0. If x equals -1, my remainder is going to be -8. So I'm going to say -1 cubed plus, now, a by -1 squared, which is, of course, just equal to 1, which is going to be a, minus 1 minus 4, okay, I'm going to say this, equals -8. So I've got -1 minus 1, that's -2, is -6. I'm going to add 6 to both sides, and I'm going to say a equals -2. Right, if you need to pause that and work it out a bit more slowly, feel free to, but my remainder is -8 when I divide by x plus 1. Then if I substitute x equals -1, I'll get the remainder of -8, and that in this case has allowed me to find the coefficient of one of those terms. Now, find the remainder when this polynomial is divided by x minus 1 squared. Does the remainder theorem work with divisors like this, x minus 1 squared? No, it doesn't. It only works with 0, so x minus 1. So I can't use the remainder theorem here. All I can do is say x minus 1 squared equals x squared minus 2x plus 1, and then x cubed plus 2x squared minus 6x plus 4. Right, we're going to divide that by x squared minus 2x plus 1, and I get an x here, gives me x squared minus 2x squared plus x, and that gives me 4x squared minus 5x plus 4. This goes into that, plus 4 times 4x squared minus 8x plus 4 gives me 5 minus -8 is plus, it gives me 3x, right? So my remainder is is 3x. Okay, so our remainder theorem doesn't work for divisors that are not linear or first degree polynomials. Rightio, so just be careful of that. Moving along now, the factor theorem is sort of an extension of this remainder theorem. So now we're talking about essentially when we have a remainder of 0. So if I have a remainder of 0, if I divide something and I get a remainder of 0, that means I must have divided by a factor. Okay, so if x minus a is a factor of some polynomial, then when I substitute a into that polynomial, I get a remainder of 0. Alternatively, if I substitute some number in to a polynomial and I get find that that's equal to 0, the value of that is equal to 0, then that must be one of the zeros of that polynomial. Right, it allows me to find one of the factors that way. Let's see how that works. Here we go. Show that x minus 1 is a factor of this. Well, I'm going to say the polynomial of 1. Okay, I changed the sign of it. Is going to be equal to 1 plus 4 plus 1 minus 6 equals 0. Okay, that'll do us. That's how we show that x minus 1 is a factor of that polynomial. Hence factorize. Well, that means that I know what one of the factors of that is. So I'll have to divide now, and I've got x cubed plus 4x squared plus x minus 6 divided by x minus 1. So we'll do this long division, and I'm going to get x squared here, and that gives me x cubed minus x squared. Subtract those, I get 5x squared plus x minus 6. And how many times does x minus 1 go into that? It goes into that plus 5x times, gives me 5x squared, minus 5x. Subtract these ones here, and I get 6x minus 6. And x minus 1, does it go into that? Yes, it does. Goes into that. Plus 6. 6x minus 6. And 0, because I need a remainder of 0. So now I have, so I can say polynomial of x is equal to x minus 1 outside of x squared plus 5x plus 6. And you know what? I can factorize this part without doing any of this long division or anything else, because it's a quadratic and we're pretty good at those. I get x minus 1. Now, factors of that, I'm pretty sure is x plus 2 and x plus 3. There we go. So we have factorized a cubic there by finding one of the factors using the factor theorem, then using long division, and then factorizing what was left. Now I could have kept testing, like guessing different factors here, and if I substitute -2 into this polynomial, again the factor theorem will tell us we'll get a 0. So if I'd tried substituting -2 in there, I go, oh, now I've got 2 of my 3 factors, and we could again do long division, or I could go hunting for the third. But anyway, there we go. Nearly done. If x plus 3 and x plus 2 are both factors of this, and you know this is kind of what we were talking about a moment ago, find a and b. Well, polynomial of -3. Substitute -3 in, will equal, what have I got? -3 cubed plus 2 lots of -3 squared plus, or let's say minus, I've got an eraser here, I don't have to rub things out, minus 3a plus b, right, and that's going to equal 0. So I've got a -27 plus 18 minus 3a plus b equals 0, and I'm going to say b minus 3a equals, what have we got? Equals 9. It's one equation. You know what comes next, don't you? Let's do the same thing for 2. I'm going to put it over here. Polynomial -2 equals -2 cubed plus 2 lots of -2 squared minus 2a plus b equals 0. Therefore, what have I got here? -8. -8 plus, what have I got here? plus a. Oh, that's nice, that cancels out. So I'm going to say b minus 2a. Oh, actually, I'm going to say b equals 2a. Hopefully I've got that right. You can pause and have a look and work it out for yourself, but I think b equals 2a. I'm going to call this equation 1. I'm going to call this equation 2, and I'm going to use the substitution method. Sub 2 into 1, and that tells me that 2a minus 3a equals 9, which means that a equals negative 9, which means that b equals negative 18. Rightio, like that. So our factor theorem tells us something, tells that if we substitute that 0 in, that I get a remainder of 0, and when we had two factors there, that allowed us to find or to generate two different equations and thus find two unknowns. Okay, I think that's it. That's it for the factor and remainder theorems. They're quite important. There's a little bit to them. Straightforward enough, I suppose, that the remainder theorem tells us that if I substitute that if I divide a polynomial by x minus a, then the remainder will be the function of a. Factor theorem extends on that and says that if my remainder is 0, then that number that I substituted in is a 0 of the equation, or x minus a is a factor of the polynomial. Okay, that's it. Got any questions? Please jot them down. Ask me in class. We'll talk about it. Thanks very much. See you next time.